Hi, all there. My name is Jeet Tilak, working as an assistant professor in mechatronics engineering department at Hindustan College of Engineering and Technology, Coimbatore. I'm here to talk about engineering materials and uh, and some fundamentals of engineering materials. So before getting to know about what is a material, what are the types of material, and how the material can be selected for a particular application. Before getting to know all these things, we should know what is material science and what is material engineering. So material science is nothing but the science which deals with the structure and the properties of the material. What is material engineering? So it is nothing but how do we get the structure and the property correlation and designing or engineering the structure of the material to produce a set of properties. And these two terms, the material science and the material engineering, as four components which actually relates these two uh, terms together. That is processing. What do you mean by processing? By processing, there are a set of processes which helps you to get the structure of the material, and that structure in turn gives you the predetermined set of properties. So these properties conclude the performance of the material in any application for that matter. So in the previous slide, I was talking about the material science and the material engineering and the interrelationship between these terms. The main four components that determine the relationship between those two terms are processing, structure, properties, performance. To explain in detail, I've taken an example, aluminum oxide material, which could exhibit the concept behind these things. Three thin disc specimens are made and it is placed over a printed material, and you all can see the picture over here. And the main property of these materials are optical property, that is nothing but the light transmittance. This light transmittance differs for all the three specimens, as you all can see the picture. So the first disc is completely transparent, the second disc is translucent, and third disc is opaque. This is purely due to the structure of this material. So the structure of these three specimens are different in terms of crystal boundaries and pores. The first material, the first disc for that matter, which is completely transparent, this is due to a single crystal structure which has high degree of perfection, which gives rise to its transparency. And the second disc, which is translucent, optically translucent, which is because of numerous and very small single crystals that are all connected, and the boundaries between these small crystals scatter a portion of light uh, from the printed page, which makes the material, as I said, translucent. The third one is completely opaque, which is due to many small interconnected crystals, but also of a large number of very small pores or void spaces. These pores also effectively scatter the reflected light and render this material opaque. So from this slide, from this example, you all can understand how a material structure is being processed and how the set of properties is being differed and how it affects the performance of the material. So now talking about the material selection criteria, there are three criteria under which a material can be selected. The first and foremost is the functional aspect. That means the in-service condition of the material. So this is served by the properties of the material, which actually in turn satisfies the application. So in rare condition, a material can have a maximum or ideal combination of properties. The second criteria under which a material can be selected is the deterioration of the material properties. It means that while service operation, a material can deteriorate in its properties as time goes on. So, for example, material can be deteriorated in its mechanical strength when it is exposed to an elevated temperature or corrosive environment. So this kind of criteria should be considered while selecting a material for a particular application. Eventually, the cost is another criteria under which a material is selected. So there is always a question like what will be the finished product cost? So if a material is selected with all required properties that satisfies the current demand or the current application in which it is being used, but still if the cost is more and if the quality is good, there shouldn't be any compromise for this. The compromising is inevitable here. So cost becomes the third criteria. And cost of the finished piece also includes, and it also uh, includes the fabrication method, the processing techniques of the material. So all these things are considered while selecting a material for a particular application. So the material selection can be done on considering the properties of the material, like mechanical property, thermal property, electrical properties, magnetic properties, chemical properties, physical properties. So talking about the mechanical properties, the strength plays a vital role in both ways, tensile and compression, stiffness, ductility, impact strength, hardness, toughness, fatigue, creep, maneuverability. Talking about the thermal properties, specific heat, thermal expansion, melting point, thermal conductivity plays a vital role in selecting a material which can be exposed in thermal conditions. And the next properties would be the electrical properties, resistivity, conductivity. So, talking about the classification of materials. So, let's talk about the solid materials here. So, it is of three types. One is metal, ceramics, polymers, and other group of engineering materials are composite, semiconductors, biomaterials. Talking about the metal are the materials which are composed of one or more metallic elements and often also non-metallic elements. So in this picture, you all can see the products made up of metal and metal alloys. So you can see a fork, knife, scissors, coins, uh, uh, a gear wheel, bolt and nut. So all these products are made up of metal. So the next solid material is the ceramics. The ceramics are compounds between metallic and non-metallic elements. They are most frequently oxides, nitrides, and carbides. For example, common ceramic materials include aluminum oxide or alumina or aluminum trioxide, silicon dioxide or silica or silicon dioxide, silicon carbide, silicon nitride. So the common objects that are made up of ceramic materials are shown in this picture. You can see a teacup, a scissor, a brick, uh, a float tile. So all these things are made up of ceramics. So this is a kind of solid material. So this slide shows you the another type of solid material, that is polymers. So polymers is a kind of material, uh, include familiar plastics and rubber materials. Many of them are organic compounds that are chemically based on carbon, hydrogen, and other non-metallic elements like oxygen, nitrogen, and silicon. So in this picture, you can see uh, some of the products made up of polymers, uh, the spoons, the forks, the knife, the bicycle helmet, um, the dyes, the tires, the milk uh, can. So these are some of the products made up of polymers. So being said about the types of solid materials, I would like to talk something about the smart materials. Smart materials are new generation material which surpasses the conventional structural functional materials. These material possesses adaptive capabilities to external stimuli such as loads or environment with inherent intelligence. So the smart material can be defined as materials which possess the ability to change their physical properties in a specific manner in response to the specific stimulus input. So in this figure, you can see some of the smart materials like piezoelectric material, shape memory alloy, electrorheological fluid, optical fiber, magnetic strip material. As I said, the smart materials are the materials which respond to the external stimuli, the environment, and it gives an output which is appropriate to implement in modern days application. In being said that the smart materials uh, can be improvised and can be developed for some kind of applications where um more precision and accuracy is required. So here, some of the future applications are listed. You can see that a smart material can be used to restrain propagation of cracks by automatically producing compressive stresses around them, that is damage arrest. So that can be a material which can discriminate whether the loading is static or shock, that can generate a large force against shock stresses, shock observers. Material possessing self-repairing capabilities, self-healing materials. The materials which are usable up to ultra high temperatures, um, those encountered by space shuttles when they re-enter the Earth's atmosphere from outer space. So these are the kind of future applications that can be given by smart materials. And here are some of the smart materials listed here. Um, so new materials, sensors, photonics, biomaterials, hybrid materials, catalysis, smart composites. So these are the materials that can be used as smart materials for different kind of applications. And thank you all for patient listening. I hope you all understood something about the material science, the selection of materials, something basics about smart materials. Thank you all.